Join us as we investigate Einstein's theory of relativity and break it down so that everyone can grasp it, from what it is to how it affects the world at large. The theory of relativity is a vast and intricate subject, so where do we begin? Some of you might not even be aware of what it is outside its name, which is great. However, I'm confident you are familiar with Albert Einstein, who developed the concept. Einstein is regarded as one of the smartest people to have ever lived, and he contributed to the way that we view the cosmos and the world. You might be surprised to learn that this extremely smart man once worked as a patent clerk. No, he really did, and this is how the theory of relativity got its start. Because he once used a trolley car to get home after finishing his duties at the patent office. And he continued to do this every single day. This is significant because he would contemplate the cosmos as a whole when he was driving. He would ponder topics and do his best to come up with solutions using the knowledge he had. And one day, while he was driving away from a clock tower, he wondered what would happen if the automobile he was in was traveling at the speed of light away from the tower. Although it may sound strange to ask, scientists are now working to accomplish light-speed travel, and these questions served as the fundamental cornerstones for this to actually happen. Back to the clock tower now. Einstein hypothesized that the minute and hour hands on the clock tower would literally appear to stop in place if you were traveling at the speed of light, which, in case you didn't know, is 299,792,458 meters per second. But he also understood that everyone at the clock tower, who was viewing events in regular time, would not see them stop while he was moving at the speed of light and experiencing a general slowing of time. The clock tower and its hands would continue to run as usual. However, in this experiment, time had actually slowed down for Albert Einstein, and it was at this point that a light bulb moment occurred to him. Because it was via this experiment that he came to the realization that traveling through space at an increasing rate actually slows down time around you. But if time was indeed a constant force in the universe, how was this possible? Einstein would turn to some of the other founding fathers of science to try and find the missing pieces in his equation. He studied Sir Isaac Newton's 3 laws of motion, for instance. Although objects do move at a particular speed, Newton points out that their values are never absolute. Primarily because each speed we travel at is determined by the force we apply to something or in relation to anything else. For instance, an automobile can travel at 65 miles per hour on a highway, but only because the surface and friction allow it to do so. No road abrasion, then? You're not traveling that quickly. It is for this reason that he makes notice of the fact that any speed must be with relation to some other force or object that is enabling or perceiving that object's speed. James Clerk Maxwell, the inventor of electromagnetic, on the other hand, points out that light is the only constant in the cosmos. Moreover, light travels at a speed of 299,792,458 meters per second. That won't ever alter. Another constant in the cosmos is that speed. Anyone, everywhere in the world, or even anywhere in the cosmos, will be able to ascertain that the speed of light is the same and that it won't change. In fact, the fact that the speed of light remains constant is one of the main reasons the universe functions as it does. But that's where the issue is, or at least Einstein saw this as a challenge. Because according to Newton, there is no absolute speed in the universe. Maxwell, however, responds to this by stating that the speed of light is always a constant. This implies that there is a contradiction between these two widely acknowledged and universal items of science. Which, believe me, is something you never want in the field of science. Here is another thought experiment from Albert Einstein to assist you understand why this is an issue if you still don't see why it is a problem. Consider yourself at a train station, standing on the platform as a storm approaches. 2 lightning strikes suddenly appear on either side of you. You see these lightning bolts at the exact same moment as the light reaches you because of your location in the middle of them. Everything seems to be in order. But this is where the equation, so to speak, twists. Because I want you to picture yourself on a train that is currently passing by the station. While you watch, someone else is being struck by lightning on both sides of them. The lightning bolts would send their light to you at different speeds according to your train speed. Let's assume the train is moving at the speed of light for argument's sake, and you are positioned to the lightning bolts because you are moving and therefore not still like the person on the platform. As you can see, depending on your position and circumstance, both laws were right and yet both laws were wrong. This is problematic for scientists and philosophers like Einstein because a scientific concept shouldn't be that flexible. Please like the video and subscribe to the channel before we continue our discussion on the theory of relativity. You won't miss any of our weekly videos this way. The theory of relativity enters the picture here. Because Einstein had to devise a way to make sense of his theory without violating either the law of Maxwell or the law of Newton. Because if Newton's rules were incorrect, physics would not be as we currently understand it. However, if Maxwell was mistaken and the speed of light isn't a constant, then the universe is experiencing light in a very different way, and we would need to ask a ton of additional questions. When Einstein saw that breaking either would be a problem, he also realized that by making a tiny, non-destructive adjustment to the Newton laws, the underlying principles might still hold true in the larger universe in which we inhabit. He gave his creation the name time dilation, demonstrating through his theory how the speed of a human traveling through space can extend or compress time. Additionally, he came to the realization that time, like space, deserved to be its own dimension rather than just a universal principle. However, according to a later theory of Einstein, this shouldn't be a distinct dimension but rather a dimension in which space and time coexist as a single entity. His belief in spacetime was born as a result, where time and space were joined in such a way that all of the universe's events occurred as a result of their union. This assisted him in constructing a new image of the origin and orbital motion of the universe. Because the majority of people think that gravity and other forces help to hold galaxies and solar systems together. However, Einstein believed his explanation was superior. The main reason for this was that, in his opinion, the sun and other large, heavy objects were warping spacetime itself, leaving the Earth and other planets, stars, and other objects in galaxies and systems helplessly imprisoned in this valley. Undoubtedly a bold hypothesis, Einstein genuinely thought it would explain a lot of what was now recognized in the realm of space science. If you're having difficulty seeing that, how about this? Think about jumping on a trampoline. Now picture placing a bowling ball on it. How would it behave? It would simply sink to the center, right? What would happen if you put a marble on the edge of the trampoline with the bowling ball in the middle? The bowling ball's valley was where it would land, so it is the correct response. We all revolve around the sun since it is the core of our system and has the largest valley. However, every single planet in our solar system, and thus every other planet in space, has its own miniature valley, which is why all of the planet's moons, including our own, rotate around them. But hold on, if you can believe it, things get worse. Since both the masses and gravities of planets as well as their distortions are subject to this theory of relativity. Time is relative to your time as you move through space, after all. That would imply that time moves much more slowly on planets with heavier gravities than it does on worlds with lighter gravities. In fact, this played a key role in the Interstellar movie's plot. In that film, 3 astronauts visited a world where gravity and light were very different since it was on the edge of a black hole. The planet was under a lot of stress from the black hole, and as a result, light's mass, gravity, and speed affected it differently. A single hour on this planet is equivalent to 7 years on Earth. The key question is whether or not it actually affects us in our day-to-day lives, even though it's wonderful to know that there are unconventional ways to view time. It's a tough topic, to be sure, so allow me to respond as best I can. However, the answer is both yes and no. Although it is possible to distort time by moving more quickly, the manner you're doing it is so minute in its dilation that it won't really matter to you. But if you pay close enough attention, you can see how time is warped. As in the case of some clocks that, although being locked in on the right time, are constantly a few seconds away from one another. Some are determined by other forces, while others are based on mathematical calculations. As a result, there are differences based on how you receive your time. It's also true that your head is older than your feet due to the fact that your feet are closer to the planet's core, where you are being pulled at a faster rate because of how the Earth functions in its time. No matter how you write it, the now famous equation that illustrates the theory of relativity, E equals mc squared, is now an essential aspect of our comprehension of space, time, space-time, and the cosmos itself. Despite the fact that it does have a significant defect. What defect is that? Simple. Consider the name of the guiding concept. The relativity theory. Keep in mind that this is primarily a mental experiment. One that depends on a manufactured object moving at the speed of light. It's improbable that we will be able to achieve it until at least the next few decades, if not the next couple of 100 years, even if we can do it right now. Therefore, we won't be able to know if Einstein was correct until we are able to enter the realms of light-speed travel. And a lot of qualified scientists genuinely question if Einstein is correct at all. And if we do find that this theory is incorrect, what that would signify for the universal truths we hold dear. Others are still exploring this idea to see how far they can take it, despite the fact that. How so? Remember the concept of space-time and how objects like the Earth and the Sun cause the space-time around them to be altered? That idea is being used by scientists to explore if they can create a ship that can travel faster than our current technology can. In essence, they are attempting to recreate the Star Trek warp engine. However, in this case, the warp portion of the engine warps space-time around the craft to allow it to travel at extremely high speeds. Something that, without Einstein and his theory of relativity, would never have ever crossed anyone's mind. You need to consider why this theory even matters in order to help tie everything together. Why is it important, besides the possible spaceship or even how it might or might not advance our understanding of the cosmos? It is a question that merits an answer, is the response. Although the speed of light and the laws of motion appear to be fairly solid constants, they really directly conflict with one another in several significant ways. When they have both been shown to be true, how is it possible? Thought experiments by Einstein may appear to be the ramblings of a man attempting to establish himself in the scientific community, yet Newton, Maxwell, and other individuals throughout history have experienced the same thing. They had an idea, a theory, and they pursued it to the farthest extent possible to see where it may take them. And for Einstein, it paved the way for the development of the theory of relativity, which launched a lengthy and fruitful career in research. Thank you everybody for watching. What did you think of this explanation of Albert Einstein's renowned theory of relativity? Do you now comprehend it, its guiding principles, and how it impacts our world? Or are you still confused and require further explanations? Please let me know in the comments section below. Don't forget to subscribe, and I'll see you on the channel again soon.